So, hello friends, welcome you all on this YouTube channel. So, this is a suspension type insulator numerical, power system numerical. So, here questions like a suspension type insulator has 3 units with the self capacitance C and the ground capacitance 0.2 C. Then find the string efficiency. So, here this is a suspension type insulator. It is having 3 units, right, with the self capacitance C and ground capacitance 0.2 C. Then we have to find the string efficiency. So how to solve this numerical? So let us first draw the diagram. So basically this is the cross arm and this is the grounded tower body, and the suspension type insulator is having 3 units. So 1 unit is this is the second unit, and this is the third unit, and here you will have a power conductor. So this is the capacitance, which is from tower body to the metallic junction. So this is known as ground capacitance, right? So this is basically ground capacitance Cg. This is again the ground capacitance Cg, right? And here this is the mutual capacitance, that is, let me denote it by MC. This is another mutual capacitance, this is another mutual capacitance, and here this is the power conductor, right? This is the power conductor. This is basically the grounded tower body, right? And this is the cross arm, right? So here the factor M will be, it is the mutual capacity by the ground capacitance. So MC by Cg will be this factor M, right? So this will be equal to, it is, he has given that the self capacitance C and the ground capacitance 0.2 C. So mutual capacitance or the self capacitance is C and the ground capacitance is 0.2 C, right? So mutual capacitance is given as C and ground capacitance is given as 0.2 C. So here factor M will be equal to, it will be equal to 5. It will be equal to 5, right? So from this you got this ratio of mutual capacitance to ground capacitance, that is denoted by M, a letter small m, right? So K is another factor, it will be equal to 1 by M, so it is 0.2, right? So KCL at different nodes, this node and this node, this, if you solve this numerical by KCL method, it may be lengthy, right? So let me give you the small trick how to solve this numerical in one single formula. For that, just keep this formula in your mind. Percentage efficiency is given by sine hn root k sine hyperbolic n root k divided by sine h n sine hyperbolic n root k minus sine hyperbolic n minus 1 root k, right, like this, right, and for percentage multiply by 100, and here in the denominator divided by n, right. So simply you have to put all these values, right. What is the value of n? A small n is given as 3 units. See this, he has given this insulator, string insulator, suspension type string insulator is having 3 discs, 3 units, right. So this is the value of n is equal to 3, right. So simply put value of n and k and get your answer, that's it. So if I put value of n and this value of k, I will get the answer in single stroke. Sine hyperbolic n is basically 3, root k is 0.2, right, multiplied by 100 for calculating the percentage efficiency. N is 3 in denominator, again sine hyperbolic n, that is root 3 into k, that is 0.2, minus sine hyperbolic n minus 1, that means 3 minus 1, that means 2. Root k is basically 0.2, right, bracket closed, and here you will get the answer. This is 77.80. 77.80 will be the percentage efficiency, right. Okay, so with this formula you can directly calculate your answer, right. So just keep this formula into your mind, that is a trick, right. So that is very simple, sine h and root k divided by sine h and root k minus sine h and minus 1 root k. So basically this is hyperbolic, sine hyperbolic and root k divided by sine hyperbolic and root k minus sine hyperbolic n minus 1 root k. So this is this formula, right. We are not going the derivation of this formula, just keep this formula into your brain and just put the value of n and k. N is the number of disk or units, that is n is equal to 3. So here n is 3 and k is the ratio, k is basically the ratio of ground capacitance to mutual capacitance. So that is basically 0.2, it is given in the question, right. So put the value of n and k and get your answer. This is the next numerical. A 66 kV system has a string insulator having having 5 discs, and the earth to disc capacitance ratio is 0.10. So calculate the string efficiency. So likewise you can solve this second numerical also. Here n is basically 5 because there are 5 discs, okay. So basically you can draw the diagram. So here there are 5 discs, 1, 2, this is 3, this is 4, and this is consequently 5, 1, 2, 3, 4, 5, and here you will have a power conductor. This is the cross arm, and here this vertical is grounded tower body, right. This is the capacitance which is called as ground capacitance, Cg, right. So here again you have a ground capacitance Cg, this is the ground capacitance Cg, alright. This is the mutual capacitance or the self capacitance, let me denote it by Mc, right, and this is the power conductor, alright. So likewise you can solve this numerical very easily. So here a string insulator is having 5 discs, so value of n is 5, value of n is 5, and the earth to disk capacitance ratio is 0.10, right? So earth, that is ground, so ground to disk capacitance, see ground capacitance or earth capacitance is Cg, and the disk capacitance or the cell capacitance or the mutual capacitance is Mc. So here you can calculate factor M, that is basically mutual capacitance to the ground capacitance, or you can say the disk capacitance to the earth capacitance. So it is given as 0.10, inverse of 0.10, right? So disk capacitance to earth capacitance is 1 by 0.10, so here it is 10. So K will be equal to 1 by M, or you can write 0.10. So K is always less than 1, right? Remember, here also in this numerical, K is 0.2, that is less than 1, right? Because mutual capacitance is more than the ground capacitance, right? So that's why factor M is greater than 1, and consequently inverse of this factor, that is K, that is 1 by M, it is less than 1. So now use the same formula. Efficiency N is equal to sine hyperbolic n root k whole divided by sine hyperbolic at n root k minus sine hyperbolic n minus 1 root k. For calculating the percentage, multiply by 100 and divide this by n, right? So just put all the value and get your answer in single stroke. So sine hyperbolic n is basically 5. N is basically 5 because it is, he's saying that in string insulators having 5 disc, 1 2 3 4 5 disc, right? H hyperbolic, sine hyperbolic 5, n is 5, root k is basically, it is 0.1, right? 0.110, right? So 0.1, k is 0.1, right? Now sine hyperbolic 5.1 minus sine hyperbolic n minus 1, that means 5 minus 1, that means 4, into root k, in that means 0.1. N is basically 5 divided by n, so divide by 5 and here multiplied by 100. So when you solve this using the calculator, right, you have to use the sine hyperbolic function, right? It is not the ordinary sine, remember this is the hyperbolic, sine hyperbolic, right? So when you solve this, you will get 66.77%. That is the answer in single stroke, right? That is the answer, right? So basically you can easily calculate this. Let me show you the calculator. And every scientific calculator is having the sine hyperbolic function. All right. So I am having the calculator, that is ES. This is the FX 991 ES plus, right? It is a Casio FX 991 ES plus. So here you see this, the hyperbolic function is basically given as, this is the hyperbolic, right? So here you simply operate this, push this sine. In first position you are having sine hyperbolic, so press 1, right, like this, and put the numerical data and get your answer. So using this calculator I calculate all the numerical data and values. That is the best calculator, right? So now I stop. Thank you very much. So like that you can solve this kind of numericals. So here I hope it is clear to all of you. So thank you very much. Thanks for watching.